Hello everybody and welcome back. We're looking now at question number 5 on the Euclid paper from 2006. So we've got two parts here, a light bulb and a written part. If A is chosen randomly from the set 1, 2, 3, 4, 5, and B is chosen randomly from the set 6, 7, 8, what is the probability that A to the power of B is an even number? Okay. So, if I were to choose something like 3 and raise it to the power 8, I'd get 6,561, which is not an even number. In fact, the exponents, the b's, don't really matter at all. So let's make that observation. One thing you could do, I guess, is write out sort of 1 to the 6, 1 to the 7, 1 to the 8. Well, each of those is 1. And you do 2 to the 6, 2 to the 7, 2 to the 8, each of those is even. You see pretty quickly that only the even base is going to matter. But the reason I would caution against doing this, I know there's only going to be 15 things to write out. 5 to the 8, if you didn't remember your calculator, you're going to have a heck of a time with that one. And you don't want to waste time on question 5 light bulb parts. So, notice that since B is bigger than 0, because if we raised A to the 0, we'd get 1, and then regardless of the base A, you'd still get an odd number. Since B is greater than 0, A to the B will only be even if A is even. So our probability rests on our choice of A. Out of 1, 2, 3, 4, and 5, only A equals 2 or 4 will give A to the B as even. So 2 out of these 5 numbers, our probability is 2 out of 5. Or 40%, but they said probability, so write it just as a nice little fraction. Okay, so that was the easy part. We justified it a little bit. We did get our final answer. And if you had to, I guess you could write out all 15 possibilities, but I wouldn't do that. It's just going to be a waste of your time. B part. A bag contains some blue hats and some green hats. On each turn, Julia removes one hat without looking, with each hat in the bag being equally likely to be chosen. So there's another probability question, I think. If the hat's green, she adds a blue hat to the bag from her supply of extra hats. And if it's a blue, she adds a green hat. So the total number of hats isn't changing, but the proportions of blue and green might. The bag is initially contains 4 blue hats and 2 green hats. What is the probability that the bag contains 4 blue hats and 2 green hats after 2 turns? Okay. Probability, so that after 2 turns, nothing has changed. Alright, so I'm going to make a tree diagram for this one. So I'm going to start with 4 blue and 2 green. Now, she can either choose a blue hat, or she can choose a green hat. If she chooses a green hat, we take out a green, so now we got 1 green, and we add in a blue. So we've got 5 blue and 1 green. If she picks out a blue hat, then we've got 3 blue, 3 green. So that's her first move. On her second move, she could again take out a blue or a green. And now if she takes out a blue, she'll have 4 blues and 2 greens left over. If she takes out a green, she will have 6 blues and 0 greens. If she takes out a blue on her second move up here, she'll have 2 blue, 4 green. And if she takes out a green, the greens will go down by 1, and the blues will go up by 1. So the cases that we're interested in are these outcomes right here. Okay. Now these outcomes are independent of each other, so what we're going to do is we're going to calculate the probability that this happens, the probability that this happens, and then add up those probabilities. Okay? When you're doing things with tree diagrams, and we've got some probabilities. Probabilities along a branch, you multiply. Probabilities from two separate branches, you add to get a total. Okay? So now let's figure out, well, what are the probabilities? You might think, and I see a lot of people do this when they hit a probability question. Every once in a while there's a probability question around 5 or 6 or something like that. Recently, at least from my perspective from recording, there was, I think, the 2015, 2016, something like that, Canadian Senior Contest, which is very similar to the Euclid in some regards. And there was a probability question. And what happened, what I saw there, and what I see a lot of people do, this is just a specific example, is probability not well taught in high school. So what they do is they say, well, geez, it can either be blue or green, so it's going to be a 50% chance. Now, if I had given the question of, we've got a thing containing 4 blue hats and 2 green hats, people can pretty quickly tell it's 2 out of 6 that is the chance the green hat is chosen. But for some reason, once they start doing these probability trees, that sort of goes out the window, and it's 2 options, so they're equally likely. I just want you to caution you, no, that's not how it works. So let's fill this thing in properly. I will use the faint yellow. Alright, so the probability that we choose a blue hat when we've got 4 blues and 2 greens, there's 4 out of 6 choices that would be blue. There's 2 out of 6 choices that would be green. Another nice thing about probability trees, if you add up all the branches coming from sort of a single node, it'll be 1. So 4 over 6 plus 2 over 6, that's 1. How about over here? 3 blue and 3 green. Well, this time it is even. So we'll get 3 over 6 for both of these. Notice that it adds up to 1, because it's all the branches coming off of 3B, 3G. How about down here? Well, there's 5 blue hats out of 6 that we could choose, and 1 green hat out of 6 that we could choose. All right. Now, we don't care about all the other probabilities, but we do multiply along a branch to get the total probability. So the probability that we'll pick a green and then a blue is 2 over 6 times 5 over 6, or 10 out of 36. The probability that we choose a blue and then a green, we multiply along the branches. 4 over 6 times 3 over 6. And that'll be 12 over 36. And now we add these up. We get 22 over 36. I'm going to divide by 2 on the top and bottom. So I'm going to say 11 out of 18. If I wanted to, I could compute these other probabilities, which I will do in, let's say, brown. This would be 12 over 36 as well. And down here, this would be 2 over 6 times 1 over 6. That'll be 2 over 6. All of these added up together should be 36 out of 36, because one of these has to happen, so the probability that any of them happens must be the total probability of 1, or 100%. 12 plus 12 is 24, plus 10 is 34, plus 2, 36. So we did work out our chart properly. Little extra checks that we can do. But our answer is going to be 11 over 18. You might say, well, you didn't really do a whole lot of explaining. You know, you can say things like, we're going to set up a chart, but it's quite clear from here what we're doing. Maybe explain that they're independent, so we add the probabilities. But there really isn't a whole lot. Everything is encapsulated in our probability tree. So that's all we really need to put. And that was all we needed to do for B, correct? What's the probability the bag contains 4 blue hats and 2 green hats after 2 turns? Bam, we're done. So, yeah, that's all we needed to do, and that finishes off question number 5. In the next video, we're going to take a look at question number 6.